This video is brought to you by Squarespace. Whether it's your new profession or just a lifelong passion, start your journey to website glory with Squarespace. Check out their amazing all-in-one platform. Link below. More on them in a bit. It's a feeling you've probably had at one time or another. That moment when you look up in the night sky with all its multitude of stars and wonder, are we alone? Are there other worlds out there? Worlds on which some alien dude is standing, looking back at our star and wondering that exact same thing? For most of you in history, the only possible answer to this question was a sort of cosmic, who knows? A recognition that there are some things that we will never truly know. At least till now. As you watch this, a vast multi-million-dollar experiment is unfolding across the planet. An experiment that's utilizing vast radio telescopes and cutting-edge algorithms to sift through petabytes of data captured from space. An experiment launched in 2015 by the late Stephen Hawking in a bid to answer one of the universe's greatest questions. Known as Breakthrough Listen, it is likely humanity's best hope of finding evidence of intelligent alien life. In today's episode, we're going to take a hard turn into real-life sci-fi and explore the awesome effort required to locate a call from ET. On July the 20th, 2015, eminent physicist and legendary badass Stephen Hawking made a speech in London, launching a project that sounded like science fiction. Backed with $100 million from the billionaire Yuri Milner, Breakthrough Listen would be an unprecedented attempt to scan the night sky for artificial signals. Not the sort of signals that might be made by probes or spy satellites, but by intelligent beings living on another world. Over 10 years, the project was going to examine a cool 1 million stars near Earth for radio broadcasts, as well as 100 different galaxies. As Hawking succinctly put it, it's time to commit to finding the answer to the search for life beyond Earth. We are life. We are intelligent. We must know. Yet, while Hawking and Milner's collaboration is the meat of today's episode, the launch of Breakthrough Listen wasn't humanity's first attempt to listen out for the culture. As Frank Drake could have told you, he had already been hunting for artificial signals for over 50 years. Although it's possible to trace back further, the modern story of SETI, or the search for extraterrestrial intelligence, really began in 1960. That spring, 30-year-old astrophysicist Frank Drake spearheaded the first serious attempt to scan the heavens for alien signals. Known as Project Ozma and operating on a princely budget of just $2,000, this attempt tracked a few radio frequencies in the direction of Epsilon Eridani and Tau Ceti for a mere 4 months. As you'll doubtless be shocked to hear, it discovered absolutely nothing. But that's not because the idea was inherently preposterous. Given humans evolved on this planet and began transmitting artificial signals, it wasn't totally bananas to think the same process might occur on another planet. In fact, demonstrating this mathematically would become Frank Drake's most famous legacy. If you're fond of Googling mind-blowing speculative space stuff, while probably stoned, there's a good chance that you've come across the Drake equation. Or written down, it kind of looks like nonsense. It's a pile of letters all just drunkenly stumbling into one another to make up a formula. It looks like what we're showing on the screen now, but it's what these seemingly random scribblings imply that's at the heart of today's episode, because the Drake equation is nothing less than Frank Drake's attempt to quantify how many detectable alien civilizations live in our galaxy. So let's just quickly break it down, shall we? That N at the start, well, that's our answer. The number of technologically advanced alien cultures out there right now shooting signals into space like a drunken redneck wildly firing his gun up into the air. To get N, we first have to look at R, the rate at which stars are forming that are cool enough and calm enough to not super kill anything that might evolve near them. Next up is FP, the percent of those stars that form planets around them. Meanwhile, NE is the fraction of those planets that are habitable. After that comes a string of stuff beginning with F that looks like made-up words that you might pronounce fooly-cooly. In reality, FL is the amount of habitable planets that eventually evolve life, FI is the number of life forms that become intelligent, and FC is the fraction of those intelligent life forms that go, man, subsistence living sucks, let's, develop detectable technologies. Finally, you get L, the length of time those detectable civilizations last before they vanish. Of course, we have no way of knowing most of these values for even basic life evolving. We currently have a sample size of 1. Earth. Hence why some people put the value of n, that is, detectable civilizations, at just 1, meaning us. But most inputs suggest a significantly higher value. Since the Kepler mission, we've known that something like 1 in 5 Sun-like stars plays host to at least one Earth-like planet that could be habitable. We're also now seeing more and more evidence in our own solar system that liquid water may be abundant, found not just on Earth, but below the frozen surfaces of moons, dwarf planets, and Kuiper Belt objects. And where we find water on our worlds, we always find life. Taken together, that suggests there could be billions of habitable worlds in our galaxy alone. Before he died in 2022, Frank Drake maintained the real value of n could be more like 10,000. That means 10,000 intelligent civilizations spread across the Milky Way, lighting up radio frequencies with chatter detectable even here on Earth. Now all Breakthrough Listen has to do is find them. At the moment Stephen Hawking made his 2015 speech, the fraction of the night sky we humans had scanned for artificial signals was pitiful. While Frank Drake's musings had led to the creation of the SETI Institute, decades plagued by funding issues had left it as an on-demand science outpost that mainstream culture refused to regard as anything but a punchline to an X-Files joke. As a result, we'd searched incredibly little of our galaxy. One calculation showed that if the Milky Way was an ocean, we'd done the equivalent of examining a single bathtub's worth of water. And of course, we hadn't found any fish. Today, though, the hunt is truly underway. The amount of data Breakthrough listeners captured and released to the public has been insane. It's been 3 petabytes by 2020 alone, all of which probably makes this the perfect moment to explain exactly what it is that they're looking for. When we pick up a radio signal, what we're basically getting is a load of information encoded into a narrow range of frequencies. For people still old school enough to own an FM radio, that information is typically audio data that's translated into music. But plenty of non-audio data is transmitted in this way too. The upshot is that we're quite used to spotting artificial signals on a radio frequency, as they tend to be much narrower than stuff created by natural processes. Sadly though, that hasn't made our hunt for cosmic signals any easier. Because as we're about to see, there are a whole ton of problems surrounding Breakthrough Listen. One of the biggest, and you probably guessed it, is interference. Our planet is flooded with human technology, blasting out artificial signals all day long, every day, on nearly all available frequencies. That means it's depressingly easy to pick up what appears to be a message from another star, only for it to turn out to be noise that we've generated here on Earth. In 2020, researchers using the Parkes telescope in Australia reported detecting artificial signals from Proxima Centauri, only for it to be later revealed that human tech had been polluting the results. Another major issue is our lack of contact with extraterrestrials. Right now, we have no confirmed alien signals that we can use as data points. That means we're limited by our own imaginations in trying to figure out what alien techno-signatures might look like. So, we mostly just sorta listen for stuff that we understand as signs of advanced communication and hope that Frank Drake's 10,000 civilizations aren't all talking via some method that we just don't understand yet. A good analogy might be imagining a spy from the American Revolution being dropped into our world and told to go and intercept enemy messages. Is he going to get a job at the NSA and start monitoring people's cell phones? Of course not. He doesn't even know what a cell phone is. He's going to be looking out for Brits with bad teeth smuggling handwritten letters on horseback. The idea that he's constantly surrounded by invisible signals wouldn't even cross his mind. Unfortunately, the human race today might be that doofus in his tricorn hat and old-timey clothes, frantically hunting for something that he can't possibly comprehend. Which may be why one of Breakthrough Listen's biggest challenges isn't designing hardware or getting telescope time, but figuring out how to tell when they've actually found something. Alright, look, we'll get back to today's video in just a second, but first, quick word from today's fantastic sponsor, Squarespace. Look, if you need a website for any reason whatsoever, there is no point. Do you remember back in the day you used to have to learn how to do HTML? I remember learning that in like computer club at school. And then it'd be like, I managed to turn the background cyan. And then I was like, yo, this is too cool. Let's get over to what in the day was GeoCities website builder. Squarespace probably have a thing in their copy saying don't mention competitors, but I think we're okay mentioning GeoCities. Look, basically, GeoCities allowed you to make a super basic website. Squarespace is basically like the 2022, or maybe 2023 soon version of that. They basically made a website builder that allows you to make a website it'll take you an afternoon, less than an afternoon, a couple of hours, and you'll have a beautiful looking website because it starts with a bunch of templates. You choose one you like, you click on it, you swap out all the lorem ipsum, you swap out the photos, you can change the colors, everything you need, and then boom, you have made a website that looks better than you imagined, with no HTML, no computer club, no nonsense from the past. And also, if you're like, I don't want to use a template, I want it to look exactly like I want, well, no problem. Squarespace is so customizable, you can do that as well. And when you've got your basic website up and running, you can add a whole bunch of stuff on there. You can put a blog on there, you can put a contact form on there, member areas, you can accept donations, all sorts of stuff. It's very easy. So go to squarespace.com for a free trial. And when you're ready to launch your site, go to squarespace.com/megaprojects and you'll get 10% off the first purchase of a website or a domain. And now back to today's video. Back in the early days, long before Breakthrough Listen, SETI types identified one frequency that could be perfect for alien signals. Known as the hydrogen line, it occupies 1.42 GHz, the exact frequency on which neutral hydrogen in space emits radiation. The theory went that with hydrogen being so abundant, other intelligences would have discovered the hydrogen line. Therefore, any aliens wishing to make contact would broadcast on it. We might even have a potential example. On August 15, 1977, the radio telescope Big Ear picked up a narrowband broadcast 30 times stronger than background radiation orbiting from Sagittarius. It was so precisely like what we'd expect an alien signal to look like that the guy who circled it on the printout wrote "wow" next to it, leading to it being called the WOW signal. Today, the WOW signal has yet to be properly explained, although astronomers come up with theories all the time. However, since it was only detected a single time for under 80 seconds, we also can't just call it a message from space and be done with it. It's not how science works. Regardless of the WOW signal's origin, the hydrogen line for a long time remained the favorite hunting ground for SETI, a choice helped by the fact that international treaties forbid nations from broadcasting on it, thereby reducing the risk of interference. The trouble is, scanning the hydrogen line comes with the inbuilt assumption that whoever is out there broadcasting wants to be heard. Hence, SETI's recent drift away from it, a drift Breakthrough Listen is only accelerating. Thanks to technological advances, scientists now scan multiple gigahertz frequencies simultaneously. This generates crazy amounts of data that forces us to take advantage of another recent advance: machine learning-based algorithms. With so much interference out there and so much data, having a bunch of interns go over every signal detected by hand would both take forever and drive all of them utterly mad. This is where algorithms like the funkily named Incoherent Tree D-Doppler and Breakthrough Listen's open source version Turbo SETI come in. Trained not only on vast datasets, but also on synthetic signals designed to mimic what an alien broadcast might look like, these algorithms eliminate background noise as best they can, then scan everything coming in for possible techno-signatures. And honestly, these software advances are the beating heart of what Breakthrough Listen is doing. Without them, there'd just be too much data to deal with. But that doesn't mean they don't have their own problems. Like the hydrogen line, these algorithms rely on human assumptions, in this case about how ET might communicate. Turbo SETI, for example, scans for continuous sine wave signals that are almost always on, but that means stuff like pulsed signals might fall through the gaps. And while other algorithms can focus on pulse signals instead, there's still a decent chance any alien intelligences would instead use methods that are, well, completely alien to us. This only gets more difficult when you start wondering why the hell an advanced civilization would still be using radio signals for communication. Like if they had an industrial revolution 10,000 years ago, it'd be weird if they were still using such primitive methods for talking. And that's why, since 2018 or so, people at Breakthrough Listen and the wider SETI field have started expanding to look at different possible markers of a high-tech civilization. Markers so extreme, they would make our Revolutionary Era spies' head absolutely explode. July the 17th, 2019 marked a turning point of sorts in Breakthrough Listen's journey. That day, their team formally announced a partnership with Veritas Collaboration, a project based out of Arizona's Whipple Observatory. An acronym for Very Energetic Radiation Imaging Telescope Array System, Veritas is an array of 4 12-meter telescopes designed to hunt for cosmic gamma rays, but it's also useful for tracking a potential communications system. Pulsing laser beams. Known as optical communication, these flashes of light, perhaps lasting as little as a few nanoseconds, are a theoretical way that a civilization could communicate between stars, intense pulses that could project information over vast distances. Of course, we wouldn't be able to read this information even if we located one of these beams, but that's not really the point. Rather, the point is that such a powerful beam, especially if it is repeated, could easily be identified as artificial, proof that some non-human intelligence had created it. And for Veritas, detecting such a pulse should be child's play. Imagine one of the most powerful lasers that we've built here on Earth, capable of emitting a 500 terawatt beam for a few billionths of a second. Well, you could take that laser, somehow fly it 1,500 light years out into the ether, and Veritas would still be able to pick it up. And Veritas is just one telescope hunting for these optical signals. Lick Observatory's automated planet finder is mostly designed for hunting rocky exoplanets, but it's also used by Breakthrough Listen for its sensitive instruments. As their website states, it can detect a common industrial laser over interstellar distances. Nor are the team just limiting themselves to radio signals and optical flashes, at least they won't be in the future. In recent years, astrobiologists have started identifying other possible civilizational markers that we might be able to look out for. While they're mostly stuff SETI researchers would need much more powerful telescopes to examine, just thinking about them is a really good starting point. One major signal could be chemical byproducts like CFCs, which are super unnatural here on Earth, but are found in abundance thanks to their use in stuff like solvents. Another could be the element tritium. Barring a recent supernova, the only way for tritium to be appearing on a distant planet is if someone there had mastered nuclear fusion. Now, detecting this stuff is beyond the telescope's Breakthrough Listen currently has access to, but that doesn't mean they won't get a chance in the future. And it doesn't mean they don't have some seriously good kit already lined up. Right now, the project is using telescopes Frank Drake could have only dreamed of back in 1960. Telescopes like the one at Green Bank, the world's largest steerable radio telescope, with a sensitivity that would put most of what came before it to shame. Or how about the Southern Hemisphere's gigantic Parkes Observatory, capable of searching 13 places in the night sky at once? Or the 64-antenna Meerkat Array in South Africa, which brings in data from a uniquely vast field of view 24 hours a day, 7 days a week. Yet, perhaps the most exciting piece of kit Breakthrough Listen could have access to is one that's still being built. The Square Kilometre Array is a project to link 2 sites in Australia and South Africa into a giant radio telescope. That means 197 dishes in South Africa, each at least 15 meters in diameter, constantly listening to the middle frequencies. It means over 131,000 antennas in Western Australia simultaneously scanning for the lower frequency bands. Taken together, they'd be able to scan anything from 70 megahertz to 25 gigahertz at a sensitivity 50 times greater than anything currently in existence. And while not designed for the purposes of SETI research, this giant array will produce tsunamis of data. Data Breakthrough Listen's algorithms should be able to work on combing through them for that most precious thing, a sign. A sign that we are not alone. And just think about that for a moment. If the project pays off, it will be the most transformative finding in modern science history. In fact, just scratch that. It'll be the greatest finding in any discipline ever. Philosophy, religion, astrophysics, morality, astronomy, the history of the universe, everything would be turned on its head in an instant if we detected just a single, irrefutable signal from another world. Of course, it may be that this never happens, that there's nothing out there, or some great filter has wiped out all other civilizations that ever came before us. But we don't want to end on a down note. So instead, we'll leave the last word to the guy who got all of this rolling over 6 decades ago, that great and sorely missed scientist Frank Drake. Right now, he once noted, there could well be messages from the stars flying right through this room, though through you and me. And if we had the right receiver set up properly, we could detect them. I still get chills thinking about it. Frank Drake may have died in September of 2022, but we can only hope that the rest of us get a chance to live out his dream, to feel the chills that would come with finally making contact with an alien civilization.